Hello, welcome back. We were discussing object-oriented programming in the first part of this lesson. We've discussed classes and objects within the concept of class and properties and methods. So we'll still be looking at methods today. We spoke about event handlers. These are basically special methods which occur when an event takes place. So if someone clicks our button 1, we can write code behind the button 1 click event that will respond to that actual event. There's also an alternate special method which occurs whenever a new instance of an object is created within our application. This is called the constructor, and you can write code in this when the new keyword is used in C#. This constructor will let you initialize the instance of the new object. Initialize could mean anything depending on the situation. It may mean you straight away set field values, some default values, or it may check for information in a file or a database. Once you start creating object-oriented applications, then it'll become more obvious what constructors actually do. So we'll look at how to find a constructor in the cars class. Go underneath the properties before the drive method and paste in some code. There are some comments above this code. Public car open closed curly braces. I'm referencing my 3 private fields, and there's a message box show called the constructor. Then we'll return to our form 1 code where we made an instance of our car. So we'll comment out on this information that we've been working with, then focus on this line of code. We'll set a breakpoint on line 23 and then run our application. Click the OK button and start to step into this line of code. You'll see it's calling a public car method. This is because car is a constructor. C# knows automatically that we wanted this method to be the constructor because we used the same name for our method that we used for our class. So it's class car and our method name is also car. This basically tells C# that we wanted to create a constructor. We want to run this method whenever a new instance of our car class is created. So we'll step into here and setting make equal to default, model equal to default, and the elapsed mileage equal to 0. And we'll open a message box that we call the constructor. The purpose of a constructor is so that we have a chance to respond to a specific event in the lifetime of our object. So whenever the new keyword is used, we can write some code at that point and then use that to initialize values or loads of other things depending on what we want our object to do. Now we'll discuss the concept of overloading. Overloading in object-oriented programming means that we create 2 methods with the exact same name. The only difference is the number of arguments or parameters that the methods accept. So for example, if we create a second car method, the only difference between the 2 car methods is that the second one takes 3 parameters: make, model, and the elapsed mileage. Instead of setting those private fields to their default values, instead we set them to values that the user gets to pass in. So at the bottom of form 1, we'll use that second constructor, the overloaded constructor. So here we're creating a second instance of car called my other car equals new car, and when I type in the open parenthesis, I get a 1 of 2. So basically there are 2 definitions for our constructor. So we can pass in no values or use the down arrow on my keyboard and look at the second version of this method called car, and I could pass in the string, make, and the model. So I can type automobile Cutlass Supreme and the 200,000 miles. And straight away messagebox.show my other car.model then run the application. Click the OK button and remove the breakpoint and continue running the application. We call the constructor and my other car Cutlass Supreme. Now we get 2 message boxes. We still have the original code here, so whenever this constructor is called, it'll call the original constructor we wrote. But under here we are creating my other car and passing in the parameters using overloaded constructor, and message box doesn't come up until later. So, overloading is something that you use to make life easier, basically. Here, instead of using the default constructor to initialize the value to some default, I may want the choice of specifying the values which will be used when initializing the properties. So maybe I can pass them in as parameters and set them at the point where the object initially created memory. So with overloading methods, meaning it could be constructor method, drive method, or anything, there is the convenience of having various ways to call the method from the part of your code that consumes your object. Basically, there are two different ways of doing the same thing and as convenience. You'll see there are overloaded methods and constructors whenever you're working with the .NET framework, especially if you're using classes. Now in the last few lessons we coded everything through a button1_click event, but as a result we could only make very simple and basic applications. Now you'll note that methods, event handlers, constructors and properties all define code blocks, and a class is the container for these things. Methods or properties can't just be hanging around outside the class. All of these things have some substance when defined in the context of a class. A class can refer to another class as long as it obtains a reference to another class. It can create a new instance of class or receive a reference to an existing object through a property or a method parameter. So our button2click event handler creates a reference to the car class. It's basically a method inside our form1 class. Our car class could create a reference to other classes of our application. Now let's talk about why we never had to create an instance of the MessageBox class before using the show method of the MessageBox object. Basically, the show method has been defined with the static keyword. This means there's no need to create an instance of the class before using that method. This is also in the case of the int.pass statement. We never created an instance of int. When a method is defined with the static keyword, it differs from a method which needs an instance to be used. The static keyword defined the pass method of the int type, and it allowed it to be used everywhere. It would be possible for us to change our car class and the drive methods, so there wouldn't be a need to use the new keyword and would always be available to use. But this wouldn't make any sense for the way we're currently using that particular class and method. It wouldn't make sense to define drive as static, because it may be that we require more than one instance of the class to find more than one car. However, we could define a new class called utility to calculate petrol prices through that particular method. So go to add new item, class, and name it utility, then click the add button. So we'll define a new method within utility. So I have public static double calculate petrol prices. So by using the static keyword in my form1.cs, I can refer to the type name utility.calculate petrol prices, then pass in 300 miles. This means we can calculate the petrol price for travelling 300 miles, and the message box can display this. So we'll see a couple of message boxes now when we run our application, and the message which appears on the third message box is driving 300 miles will cost $105. So basically we could create a utility class that has helper methods, and these work without us having to create an instance of our utility objects. These are called static methods, or sometimes called static classes. That's if you are including some static methods in a single class. So basically, just remember, some methods can be defined in a way that doesn't require an instance of that class to be created first. Now we'll discuss public and private. Public and private are types of modifiers. Modifiers change the visibility of that particular code block. So we'll discuss the use of modifiers in terms of classes, properties, fields, and methods. When we design a class, we want to show some things and hide certain things to the code that uses an instance of that class. Anything with the keyword private will not be accessible by the code that creates an instance of our object. In our class, when we defined our fields, The only way that the code could get back and use the value that's stored in these fields is by using its associated property. These properties are marked as public. Now, if I change the _makePrivate field to a public field, let's go back to our form1.cs to my car, and we can see that I can use it because it's visible within the IntelliSense. We'll set the make to Chrysler. Now if I go back to Form 1 and run the application and try to change it back to private, I get a compile time error. I get a message saying that it is inaccessible due to its protection level. So this means our private field is protected from anything outside, so it becomes inaccessible to the code that tries to reference it. So it's only through the public property, which has the same name, they can reference them. Now this is a very important thing to note. I'm using the keyword private for my field, but I'm using the keyword public for my properties. The reason is because I want my properties to be visible by the code which created an instance of my car class, so that my button2click event can set and retrieve the properties I've defined. By setting the properties to private, it would render them useless. Now, the reason there is a separation between the storage of a given value in a field and the process of storing it through the use of properties is because there is something in object-oriented programming called encapsulation. Similar to a TV remote control, you're not interested in how the technicalities work and what happens inside the remote and how the sensor sends a signal to the TV. That's all hidden within the remote behind the plastic cover. You're just interested in being able to change the channels from one to the other. In the case of creating classes, it's a similar thing. You'll want to keep the technicality of how the class works hidden from the code that wants to create an instance of that class in an application. Basically, there are certain things you want to keep private and others public. Another name for this is black box programming. This means that a class is like a black box, which just works. You don't have to see the code in order to be able to use it for your application. The reasons for this could be that you want to filter out the values for your properties, which might mess up your application. In this case, you want to control assigning the values and filter out the bad values. Now this concept of encapsulation is very important. We'll talk about how we change the make property to accept the values that our application can understand and filter out the others. Go to your make property, comment it out, and remove the current set statement. Then paste in some code and replace it with a new set statement. Here, we're filtering out all the values except those equal to Oldsmobile or Chevrolet. If the value isn't equal to Oldsmobile or Chevrolet, then we'll assign it to an empty string. We'll set a breakpoint in this line of code. Then we'll go to our form 1 and set it equal to Oldsmobile. Then we'll step in 2. We'll then change from the constructor's value default to Oldsmobile. And stop the application and change it to Toyota. Copy and paste this line of code. Then do messagebox.show, new value, mycar.make. Now let's see if it will allow the assignment to Toyota to happen. When we run the application the second time through, we hit the breakpoint a second time and the value is Toyota. You'll see the code skips over the assignment because it's not equal to Oldsmobile or Chevrolet. So we're in our else statement, so make equal to empty string. Once we get to the message box, we'll retrieve the value, then the get statement will display our message box. There's an empty string after the new value. So this is how to control filtering out values using a set statement. We've also used encapsulation to protect the assignment of the underlying private fields, the member properties, to make sure that the values are within the expected range. You can also mark methods with the visibility modifier. Methods which are public can be called from the code that holds the reference to the instance of the class. If the methods are private, they're usually called helper methods. Methods that perform some small part of the overall function of the public methods in a class. Those methods can be used to break down the functional bigger method into smaller methods. This way it becomes easier to manage and understand. So now we discussed encapsulation and said it's one of the main tenets in OOP. The other one is called inheritance. So basically, if you're creating classes, there may be occasions where you need a more specialized version of that class. We could create a minivan class. The properties of a minivan are similar to those of a car. There could be a few extra properties that could be added to the minivan class though. The drive method would still apply, but the way that the method is implemented, the code that's inside the method's code block, would be a little different. It's possible to create a new class, copy and paste all the code from the car class, and put it into the new minivan class. But then, if there's a problem in the code of the car class and we needed to fix it, we'd also need to fix it in the minivan class. It becomes a problem if there's a lot of specialized classes which have been created based on the car class. So a better way to do this is by inheriting from the car class. The car class would be a base class, as it is the parent of the more specialized class. But I want to do something different. I want to show you that the other classes can also be within the car class defined in car.cs. So the same file can be used to define another class. The way we do that is by making sure that we're inside the namespace of curly braces and outside the unit of the last curly brace for the car. Then I'll paste some code in between those two. So I've defined public class minivan : car. Colon means there's a connection between these two classes, or you could say minivan is a car. This basically means that car is a base class and minivan takes most of its functionality and specializes the functionality of the car class. So now there's no need to write all the code that I wrote for the car class to get the same functionality inside my minivan class. I just need to add and overwrite things that distinguish minivan from an ordinary car. So you'll note my new constructor for minivan works a lot differently than the car constructors that I created. You can also see in another line that I defined an additional private field and a public property called passengers to keep track of the number of passengers that I can hold. I've also overridden the default functionality of drive with my new functionality. I've calculated the cost of driving the minivan and adding that into the result string. So now we can save this. Now, even though the fields are private, I can still reference the make, model and the elapsed mileage. I do need to make an alteration to my car class and change the visibility to do something called protected. This means that only the classes that derive from the car base class can access the values that are denoted here. So protected is somewhere between private and public, and we use it whenever we're working with inheritance. So now in Form 1, in our button to click event, we'll paste some code. I created a new instance of my minivan. Even though I didn't define the make, the model and the elapsed mileage properties of the minivan, I can still refer to them because of the relationship to the car class. It's also possible to reference and set my new passengers property, and I'm calling my new overridden method drive. Here we seem to have got some error messages come up. It says that if we want to hide the previous functionality of drive, we need to use the new keyword. So basically, back to our car class, we want to use our new drive method instead of the old drive method. Both have the exact same method signature. We need to tell C# that what we intended to use the new keyword. Now let's run our application and you'll see we get the constructor message twice. And we get Town and Country now has 2,530 miles costing $10.50. So now to see why the constructor message came up twice. The first time we call it should be here. However, we've already defined our constructor for our minivan, so there's no need for the constructor to be called a second time. So we'll set a breakpoint in the car constructor and one in the minivan constructor. We'll run the application again, click the OK button. We'll step into this line, and the first thing it does is call the minivan constructor. But after that it calls the car constructor. This is because we're driving our minivan from the car class. It shows our constructor as we continue through, and then it will execute the rest of the code within its constructor. The value of make will then change from default, which was set in the previous constructor, to the new value NA, not applicable. So when working with constructors of the derived class, the constructor of the base class will be called before the constructor of the derived class. So basically we've touched on the basics of inheritance and how it works. Now let's look at some of the benefit of object-oriented programming. Initially, they appear as if they'll make your life a little more difficult, but as you develop applications, you'll find using object-oriented principles make life a lot easier. The first benefit is when designing your application. OOP begins with analysis and design. It gives a logical way of breaking down a big problem into smaller, easy to understand pieces. You think of the main classes of your application and slowly begin to add properties and methods to each of those classes, charting the interaction between the classes. The second benefit is if you keep everything related to, say, a car in one class, it makes it easy to change how your application functions by just changing the code in one place. Now say you wrote your application in a very untidy manner. There are various places in the application which let the user alter the information that's related to the car. And say one day you need to change the way the application modifies the car info. You'll end up having to hunt through all the code you've written and through various forms and files to find where the car data is modified in code. When you eventually find that code, you then need to carefully change it, hoping that you didn't miss or forget anything. If you miss any of the code, that needs to be changed, and you'll face a lot of problems. You basically have a much bigger application, thus being more difficult to update, and as a result there'll be a lot of unnecessary extra work. Through object-oriented programming, you just need to change the method in the car class that modifies the data, and that's it, complete. So the third benefit is that by encapsulating functionality in your class, the code that creates and uses an instance of your class might not have to be changed, even though you update how your class operates internally. There's also the benefit of reusability. So all the code related to car is in a single class. That class file could be copied and used in other projects. There's no need to rewrite any code to gain all the benefits of your car class. You've saved time by having worked out all the bugs by designing, developing, and debugging all the code. So, anyway, I do hope you enjoyed this lesson. It will take time to understand all of this, and even months or years to master the concepts of OOP. However, don't let that put you off. Keep on learning and building applications. And until the next time, do take care, and I'll see you. Bye bye.